devices that has to be managed. Noise has to be managed. If it is possible, it should be eliminated at device level. Then only this higher level of integration becomes meaningful. Otherwise, we have more problems and less solutions. Understand now? This is what this medium processor diagram. We have different medium process. Clearly, this picture shows you that yes, there is a smartness that comes to the space. Right? Next. This is advantage is you can see better planning of an IC area in this when compared to older version. Cost. The cost wise also how the die cost varies and how many layers. Layers in the sense the advantage of MOSFET is it is layer technology. For example, like a duster. The hooks are there. Any 2-3 hooks are there. An epitaxial layer. Upon that I have a metallization. So all are layers only. Got my point? So as we have layers, this inherent layer mechanism. For example, this is a layer, this is a layer. So in between, if you have a space, spacing will be there, no? When we have different layers, these inherent layers actually contribute to a kind of capacitance. So you will find the capacitances. For example, oxide layer is there, semiconductor is there. Between oxide and semiconductor, we have an interface here. This link is called as interface region. This interface region will give you a capacitance called as interface, what is CIT? You call it as interface capacitance. Oxide semiconductor, interface capacitance, and we have junction capacitance. Various capacitances are there in MOSFET. That is the relation. If the technology changes, the number of layers also changes. Suppose 60 nanometer technology, X layers. 90 nanometer technology, number of layers changes. Very good book to understand this layer concept is Douglas Bucknell. VLSI designed by Douglas Bucknell. In the book it is very clearly mentioned. Diagram will see what is the technology behind it. Next. It acts as a switch. Fine. This is a switch. I am talking about a CMOS inverter. Okay? A CMOS inverter I am talking about. This is PMOS transistor and this is NMOS transistor. These two transistors are operated or are pushed by the input voltage. NMOS will be active. When NMOS is active, this switch will be closed. Right? This switch will be closed and this will be open. When this is closed, what is the voltage? This is low value. That is by inverting action. Be open, this will be closed. Because PMOS transistor is active for lower voltages. Okay? In this case, this high value will come here. So you will get this. Transistors or CMOS or NMOS, whatever it may be the logic that you are talking, basically they work like switches. Okay, switching activity. Now I will tell you one interesting point where normally we tell to PG students, you also can understand it. Switching activity. Switching activity in the okay, you just tell me the scenario. If he is not traveling, what is the amount of time you will be having with him? Or what is the amount of energy? Energy may be money. Money is also a form of energy, no? Right? What is the energy that he would have if he is not traveling? And because of traveling, what he lost? Because of traveling, he might have gained some knowledge, right? But in other ways, this traveling might have brought some kind of fatigue. Fatigue means inactiveness. Every day you have to travel, no? You shell out your energy or not? Yes? When you travel frequently, when you change the positions frequently, what happens? Energy loss. Are you clear with this? Now you take the switch. Switch on, switch off. Switch on, switch off. The switching activity. When the switching activity is more, power consumption is less or more? Power consumption is less or more? More. That's what happened with yourself. When switching activity between Chennai, Trichy, Chennai, Trichy, Trichy, Chennai, right? always communicating or commuting between these 2 points, 2 stations. Loss of energy only. Yes, loss of time, loss of energy. Here also switching activity actually incur some power loss. This is called a dynamic power dissipation. What do you call it as? So that means when position is changing, dynamic power dissipation. There is another one, static dissipation. Static dissipation is in the same classroom. If I am standing like this, like a mic, if I am standing, as such I am saying Vande Mataram or Janaganamana, if I am standing and speaking continuously, I lose some energy because of this position. Right? So that is why I am making some moves. I am making some moves here and there. Right? To gain the energy. Because when I see different people, different faces, I will be activated. That is my way of getting activated. Right? So by virtue of position also, if you sit in a position for continuously, then also you will lose energy. That is called as static energy loss. In terms of circuit, when you have more number of components in a circuit, this complexity will also demand more power consumption. Right? So because of switching activity, one power consumption. What do you call it as? Dynamic power consumption, which is a small disadvantage when it comes to many circuits which are realized using switches. Next, very interesting concept it is. Sir, I have insulators, I have conductors, I have semiconductors. Fine. Conductors means speak differently. Conductors means highest level of performance. For example, okay. Insulator means lowest level of performance. Semiconductor means partial, okay, or intermediate. We generally are interested towards highest level of performance, no? Every day we demand highest level of performance, right? Yes? Then you could have worked out with semiconductors, no, instead of semiconductors. Why ICs are fabricated using semiconductors? Because conductors should be there, right? Because ultimately you want everywhere maximum performance. Your maximum performance is achieved using conductors. Why you go with semiconductors? I will ask in another way. You are going to a supermarket, okay? In a supermarket, after going to a supermarket, will you ask for good product or bad product? Give me some good oil or bad oil. You are going to a cloth shop, ready-made showroom. Show me some good trendy designs or old-fashioned designs or floral cloths. Which you ask? Good trending, right? Good everywhere you want quality. But if you go to this foundry, you are asking, give me something impure. Yes? Only in semiconductor industry we ask, give me something impure. Why? What is the reason? Even in day-to-day life itself we ask for purity, no? Only in semiconductor why you ask for impurity? Because doping is nothing but impurity only. Why you ask for that? Any reason? Doping increases the conductivity. What it does? It increases the conductivity. Understand? So that is why we require doping here. So N type of impurities as well as P type of impurities are added to increase or enhance the conductivity. Fine. So P type semiconductor is taken, N type semiconductor is taken. Please see this. P type semiconductor is taken, N type semiconductor is taken, both are that means extrinsic. Example of extrinsic, you are adding them. Adding means it is not just taking a polygon and just connecting them, right? A crystal is grown with a material called as galena. What is that? The material name? Galena, and a PN junction is formed. PN junction only formed. When you connect the terminals, PN junction diode is formed. Understand? There is a difference between PN junction and PN junction diode. When back-to-back PN junctions are connected, transistor is formed. Right? Then MOSFET has come into picture. That means doping is very essential phenomena to improve the conductivity of semiconductor compounds. Yes? After gallium arsenide, gallium kinds of materials or semiconductor compounds that have come into picture, apart from the silicon which we regularly see. Next. It is 2.5 times more than Bohr mobility. Yes, this is what people say. Electron's mobility is 2.5 times the Bohr mobility. Then I want to ask a question to you. then you would have taken only NMOS transistors, no? Because what are the majority carriers in the NMOS transistors? Electrons. Minority carriers? Holes. PMOS transistors? Majority holes, minority electrons. Then mobility of electrons is more than mobility of holes. This is what people say. Then you could have designed circuits only with NMOS transistors, no? Why you take PMOS transistors? Because CMOS logic you are studying right now. In CMOS logic, pull-up network, what it contains? Pull-up network, P-type transistors. Pull-down network, N-type transistors or NMOS transistors. Why you combine them? What is the reason? Anybody in the class? That concept is finished. Mobility of N-type transistor is more. Use only N-type transistor. Why you go for PMOS again? Again in textbooks, if you carefully see, you will have a diagram called as DC characteristics or transition characteristics. If you say this on and off state transition, for example, you are designing a CMOS inverter, right? If you use only NMOS transistors, this particular gap will be more, right? The delay that comes in the transition of on to off is very, very more in NMOS logic, but whereas this gap is almost ideal or less in the case of CMOS logic. That means on to off transition is very, very fast in the CMOS transistor or CMOS logic when compared with the other logics. Got? And there are other factors also at your level you can understand at this with this knowledge, right? So what is the answer? Using CMOS logic, the on to off transition time can be reduced. That is why we use CMOS logic. Next. The other one is macroscopic. Microscopic means all the issues like noise. If I have given mic to each and every one, the auditorium is too large. So I need to connect. So how can I do? I can do in different ways. I can have a wire, each individual wire to each and every mic, and we can connect it. Or I can take a very long, what you can say, it's a like cord like stuff, and from the cord you can take individual wires, very long. So similarly I say that every kind of circuit, a sequential circuit, may be in need of a clock, right? Mostly it is in need of a clock signal. So to every corner of this particular fuse circuit, if you want to apply the clock, there are many types. One popular one is H-plane tree. What do you call it as? H-plane tree. So like English alphabet H, you can organize your clock to different branches of the circuit. This is one method. Now the new method is Intel has introduced in 2009 in a white paper. It is called as centralized clock, or you call it as system clock. In the sense, it runs throughout the system. Suppose if you take, this is a circuit and this is the global clock, and whenever it is needed, the clock is taken to the particular components which are connected on either side of this center clock, right? A system clock that runs through it. So this is one approach that which has come into picture in the recent advancements. Now the other one is macroscopic. Clock management is very, very important when it comes to VLSI circuits. Okay, time management or clock management is essential in managing in getting the circuits more efficient. When it comes to macroscopic issues, these are marketing issues more or less. They are marketing issues. Time to market, time bound activities, how you are bringing your testing into picture. Testing into picture means from your syllabus I have seen even testing is also there for you, right? The new kind of advancement in testing is DFT. DFT means design for testability. You can note down. The new advancement technique in testing of VLSI circuits is DFT, design for testability. You have internal marks, internal assessment exams are there, midterm 1, midterm 2. Shall I ask a simple question to you? Exams are there, directly university exams, one shot. Yes. But the system what we are having is continuous assessment. Yes? Now we come here. First case is the product is tested once after it is completely manufactured. Like no exams, only university exams. First case. Second case, product is tested in the process of fabrication. Right? In the process of completion of this course, you have been tested many times. This is called as online testing. You call it as online testing. Right? So online testing is something where when the IC is in the process of fabrication, then and there at every stage it is being tested, verified in its functionality, in its timing and other factors. Right? Instead of testing it after the completion of the product. So this is a new method of testing, and design for testability is one step ahead. That means sometimes testability becomes very difficult. It is only 60 people in this classroom. After noon, I hope so that the number increases. Right? When the number increases, if there is one guy whose body language is little different, it is very difficult to identify, because in a classroom of around 200 students, for a lecturer very difficult to identify who is very uneasy in the class. Yes, now it is very easy for me because I am panning to everybody equal. Got my point? That means when the system is less complex, it is easily testable. Please understand this point. When the system is more complex, testability methods should be updated or upgraded. So the design for testability is nothing but designing the system which is very easier to test. Right? At your level you can understand like this. Designing the system in such a way that it is testable at any stage of application. This is a new method of testing methodology. Next. Before entering into the foundry, that means dust-free environment it is. So two things are normally taken from temperatures as well as poisonous gases will be there in the process of fabrication. Right? So we have a risk of getting exposed to poisonous gases, high temperatures, and we should maintain clean environment in the foundry. That is why these kind of dresses they use while handling those equipments. Next, kind of components. Next, the vapor. Out of this vapor, the batch processing. What do you call it as? So nearly 24 vapors generally they will consider and they will process as a batch. Fine. Next, as NGS. What they call it as? Electric gated silicon, which can be fabricated further. And one slice has been taken like this, which is called as vapor, and it is sectioned. Next month, you see this. So everything what I have shown there, it is in the form of pictures. This is called as ingot. What do you call it as? Ingot means a cylinder-like structure. Right? This cylinder-like structure is sliced after into vapor. Right? Sony or you have Lenovo outlet is there. Yes? Directly you go to that outlet, get one product, one PC or laptop. That's all over. HP. Okay? Instead of that, if you assemble the computer, you take a keyboard, Intex keyboard, or some other mouse, okay, some gigabyte processor. You take different kind of processors are available. Yes, different kinds of motherboards are available. You assemble all of them. Take individual components, assemble them. This is called as semi-custom. What do you call it as? If you do it from scratch, you call it as full custom. In IC designing also two types are there. One is semi-custom and other one is full custom. So the standard cells are useful when you go for semi-custom IC design. Fine. Next. So everywhere we go for this simulation and synthesis. So this is requirement. Requirement means I need to design a circuit. The circuit is, you should say the answer for this. I need to design a circuit where if you give yes as an input, you should get no as an output. Just like classroom. If lecturer says yes, student says no. Right? If lecturer says no, student says always there is a gate that is connected between lecturer and student. What is a gate? Not gate. See the girl how she is saying. Not gate. Not gate 7404 means for the not gate A is input, A bar is output. Suppose that is my demand, that is called as requirement. For that, I will write a logic. What is the logic? Y is equal to X bar is the logic. So this logic is written using any language like PSDL, which you call it as RTL design. RTL design means register transfer logic. RTL means what? Register transfer logic, which we normally do by programming. Using any kind of result synthesis, we use this kind of programming. Okay? And I need to tell two types here. One is analysis, other one is synthesis. You take any kind of engineering, whether it's CSE, IT or ECE or EEE, these two concepts will be very, very important. One is analysis, the other one is synthesis. What is the difference between analysis and synthesis? After finishing this class, right, before lunch session, while going out, students will have different discussions all over the class. Interesting, not interesting, boring, average, good, bad, different comments, no? The same thing we are having a habit of doing even after watching a movie also. Hero is bad, heroine is good, music is bad, story is good, director is bad. Yes? What do you call it as? Analysis. What do you call it as? Analysis. Once upon a time, one famous scientist also said like this. Analysis makes the man paralysis. What is that? Analysis makes the man to paralysis. Paralysis means what? You paralyze that activity. You can't do analysis forever. Right? Suppose tomorrow some culturals are coming to your campus, your campus is conducted. So you are asked to go for a short film. Then only you will understand the difficulty of direction. Then only you will understand the difficulty of action. Then only you will understand the difficulty of background score and editing. Am I correct or not? So commenting is very easy, analyzing is very easy, but preparing is not so easy. Yes? So that means preparing is challenging. This is called as synthesis. What do you call it as? So synthesizing means getting the work done in different ways. Getting the same work done in different ways is called as synthesis. Synthesis offers creativity. Synthesis always offers creativity. So VLSI technology has got both of them. It has got analysis as well as synthesis also. Understand? Any response is there. If you are explaining about the response, it is called as analysis. If you are explaining about methods how to get this response, it is synthesis. Yes? Are you clear with this? Are you clear? Next. So these are the things. First we have everything what I told from last half an hour or so. I am summarizing here. I am taking this molten silicon. The molten silicon is got into ingots. Then it is etched, polished, and then you will be going for photolithography, and finally you will be getting it as a product or in an IC form. Okay? Next slide. We have various other spice versions like H-Spice is there, T-Spice is there, various spice languages are there. Spice means simulated program for integrated circuit emphasis. We write a simulation program and we do it. Do you have spice program? Spice lab you are having? Syllabus? Yes. Next. So these are the analysis which we can do. What are the analysis which we can do? VLSI analysis, DC analysis, noise analysis, transfer function analysis, Fourier analysis, Monte Carlo analysis, worst case analysis, sensitivity analysis, various analysis we can do. Why we have to do analysis? To see the characteristics of the output. To understand the characteristics of output. Right? So the analysis will be helpful to us. Now, the advantage is, if you want to do noise analysis, you could have performed AC analysis. That is the condition. If you want to do transfer function analysis, you would have performed DC analysis. Right? Next. So what are the components that are available? Almost all passive and active components that are available in the IC, including the bulb. Okay? including the transformer. All the components are available in this library. Next. This is how we enter into it. In your computer, go to all programs, PSpice, then you go to schematics. Okay? Next. After that, you will get a window like this. Then select a U part from this. This is like a breadboard like platform. Have you seen this? Have you seen this? Next. Then we will select the voltage source, whichever you want. Next one. You are placing that RCAD capture here. Like that RCAD PSpice AD is also there. PSpice AD is nothing but programming. Capture is nothing but drawing the circuit or simulating. Okay? Next one. Now then we are selecting a wire and we are connecting. Next slide. And we are placing the components. I don't know resistors and all we can place. Next slide. So we are placing the ground. I am selecting the ground and placing it. Next. So I have placed my ground and couple of components I have placed, including the voltage source. This voltage is for say about around 12 volts. Next. After that I want to connect all of them. Next one. Just I am connecting with a wire. Okay? I am using a wire and I am going a little faster because we have many things to discuss. Next. So I am finishing this complete circuit. What I have done? I have taken the parts individually. I have taken the voltage source. I dragged and dropped onto the workspace and then I have connected using a wire. Now I made my circuit. Next thing what I have to do is, I just have to place some probes. Probes, CRO probes are there, no? Just like that I have to place some probes. Next. See. Next one. See, voltage probe. Next. I'll show what is the probe. Next one. So this is current probe, current value. Next. After placing the probes, when you simulate, you will get a black color window like this. So this black color window is a graphical user interface and this is called as a trace. What do you call it as? Trace. So x-axis you can choose. Y-axis variable also you can choose. Understand? X-axis need not be time always. It can be voltage also. Next one. Next. What you cannot do using, what is the limitation of RCAD PSpice? Textbook says that it is having a limitation of around 68 nodes. Okay? RCAD PSpice generally works on KCL, Kirchhoff's current law. But people say it is 68, but we have seen up to 140 nodes also. Okay? We have simulated even more than 140 nodes using PSpice. So node limitation is one such. And second one is power consumption values. Sometimes it throws negative values, which is absurd. That is what one kind of aspect that you have to look into when you do this RCAD simulation. Next one is what? Is once again a trendy topic. What is this? 3D VLSI. It's a mixture of old and new I am speaking about. 3D VLSI. What is this 3D VLSI, sir? I will just bring it to your level. Right? So I have two planes like this. Right? This is plane 1 and this is plane 2. If I am laterally connecting these two, we call it as 2D. If I place like this, the space occupied by this configuration is more or this configuration is more. First one is more. Second one is less. Now how do you connect this? Vertically. Yes. I will have vertical connections. This is called as 3D VLSI. Yes. In short, at your level, if you want to understand what is 3D VLSI, 3D VLSI is bringing you one more factor called as altitude into picture, height into picture. What is the advantage of this? Packaging density will be more. So this is what your power consumption can be calculated using a formula called as P is equal to CV square F. If you want to get a low power circuit in VLSI, what is the formula that helps you to do this? P is equal to CV square into F. F is frequency, V is voltage and C is capacitance. Okay? Next. See this. This is what 3D VLSI is all about. Just now I have shown now using books. Next one. Yeah, next one. This is about testing. Testing aspects also you are having, right? We have fault simulator in the VLSI design process. So before going to do this, I just want to tell you what is the difference between testing and verification. Okay? Very basic things you want to understand. Even computer students can also answer. What is the difference between testing and verification? Because in IT industry, most of the jobs, 70% of the jobs today is on testing only. Right? So what is the difference between testing and verification? If a lecturer asks a question to a student without knowing the answer, what is this? If a lecturer asks a question to the student, take for example without knowing the answer, you can call it as testing. Yes? Testing on. If a student asks a question to the lecturer by already knowing the answer, then it is called as. So student is verifying whether lecturer knows or not. Understand? So the second one is verification. First one is testing. In the case of testing, you may or may not have an answer. But in the case of verification, you have an answer. You want to check whether the same answer is getting or not. Yes? So that is the difference between testing and verification. In VLSI, normally we go for testing and verification also. Both will take place. Before that, we have to define what is a fault. What we call it as a fault. Right? What type of faults do occur? Fault means what? What do you call it as a fault? Huh? Error. Fault and error are same? They are different. Fault and error are same or different? Then what is the difference between fault and failure? Fault and failure. We choose by the force of parents than our own individual interest. Yes? Mostly those students will be sleeping in the classroom. Right? What is the reason for getting sleep in the classroom? The reason is choosing the course without interest. Yes? Choosing a course may be a fault, but not completing the course will be a failure. Got my point? So that means failure is in the larger sense and fault can be rectified. Fault can be rectified. Got my point? Even though you have chosen a course by force, but still you can develop interest on this. Still you can rectify that fault. But failure, in most of the occasions, you cannot rectify. Failure is something which is permanent and fault is something which is temporary. Even if you ask me one step ahead, beyond technical reasons I explained, even failure is also temporary. Right? Generally you ask, other than technical information, you ask me, sir, can't we overcome the failure? You can overcome. That is what Henry Ford said in the very first slide of this session. Failure is nothing but this time starting more intelligently. After a failure, this time you have to begin more intelligently. After failure, there is something which is called as success. I just have to tell you one simple incident here. Simple incident is, have you read Bible? Anybody? Bible? Anybody? Have you read Bible? In Bible, there is a very famous story called as Beethoven's story. Beethoven's. The story is all about, forget about all these things. He is a very great musician. Okay? Very great musician. At the end of his concert, somebody comes to him and asks, sir, you have played very well, sir. You have given wonderful music. If I have to become like you, I would have given my life. This is what the statement told by the audience. You know what he has said? Sir, exactly I have done that. What he has done? I have given my life, sir. I have practiced this much to play the music like this. Right? So you are expecting that I have to give my life to play like this. I have given already my life. So giving already is life in the sense what? If he thinks it as a failure, it is a failure. If he thinks it as a success, it is a success. Because many people are enjoying it. Got my point? Many places when I go, people ask me, sir, how much time you prepare? Right? How much time you prepare to a classroom or to addressing a gathering? I say no time. Because interest only in this my body. I don't find any time, in fact, to prepare. Even your flights also I did it yesterday night over traveling. So in the sense, when you put your interest, your complete interest in doing your work, you can note down. All is having some characteristics: nature, extent, location, and duration. Nature, extent, location, and duration. These are called as odd characteristics. Ghazani movie, have you seen? What is the specialty of the movie? He is having a short term, like ATM, it is STM. Okay? He is having a property called as STM, short term memory. For every 15 minutes, the counters will be turned to 0. Reset counter here turns to 0. In this sense, this fellow's font is not permanent, it is only temporary. That means for every 15 minutes he need to update, he need to be updated. So it is having some time. Correct or not? And there are some other movies where when a person goes to a place, suddenly old life stories are comes into mind. Correct or not? It is location. What is that? Font identification by location. So location is there, as well as time is there, nature also there. Nature means what? Onion movie. Onion movie, have you seen that? Split personality. In a single individual, how many personalities are there? Ram, Raymond, some other characters, right? So person after person comes here. So it is about nature of the part that you are addressing it. This is generally speaking. Here we have two parts. Stuck at 0 part, stuck at 1 part. Another part, stuck at 0 part, stuck at 1 part. That means that particular point of the circuit is always maintained at 0, logic 0. That particular point of the circuit is always maintained with logic 1. So these two points are called as stuck at 0 and stuck at 1 point. There is another part. Other part is you are coming from Chennai to Trichy in a general compartment, for example. Okay? So many people are sitting in the same bench. Then why Chennai to Trichy? In your classroom also, instead of 3 people sitting in a bench, we all are friends. 5 people, 4 people, all are existing in this given space. In winter season it is okay. Summer, yes, correct or not? So same thing happens when you take high density memories. In high density memories, when the package density is high, one memory location and another memory location are very close to each other. Suppose 0 is stored in this. The same 0 will be influencing this location also. After some time, 1 in this location will be turned to 0. Or if no data is there in this also, it is induced with 0 voltage. This is called as coupling fault. What do you call it as? Coupling fault. When it comes in memories, high density memories. This kind of fault should be identified or tested. Fine. I will do one small thing here. You just follow me. Say 0. 1. We are electronics people. We don't have 0, 1, 2. We have only 0 and 1. Okay? 0. What is the number told by that girl? Please tell this. What is the number told by that girl? 1 or 0? How do you know this? Difficult, right? We are very busy in seeing who is saying 0 and who is saying 1. But we never maintain any data of that. Yes? Correct or not? So that means I have done this thing immediately after asking her 0. If I ask her now what she said, means easily she says 0 only, sir. But I made it for 2 rows, then only I asked the girl. This fault is called as data retention fault. What is this fault? Data retention fault. That means the fault of a memory location after some time is easily identifiable. In the sense, when you store some data in a memory location, and after some time if you check the data in the location, if it is there, it is fault free. If it is not there, that particular location is suffering with data retention fault. Okay? It cannot maintain the data for a long time. So for that what we have to do? Periodically we have to test that location. So this is one of our testing methodology. Right? Time and again we have to test it. Understand? So all these things put together can be done using some test vectors. Now just now I have given one test vector to this branch of to the group of students. 0, 1, 0, 1, 0, 1. This is a vector. Yes. After that if I use 1, 0, 1, 0, 1, 0, this is another vector. So I will use test vectors, I will test the locations and I will identify whether the memory location is faulty or fault free. This is called a fault diagnosis. What do you call it as? Unfortunately today's doctors are not diagnosing the fault, they are diagnosing the pulse of the patient. Correct or not? Difference between, forgive me if I hurt anybody's sentiments. Previous days doctors generally, I have listened from my grandfathers and all, when you go to a doctor used to take your hand and used to observe the pulse and says, what is the problem of it? Even by seeing also they used to say, like this kind of problem this guy is having. Today, doctor is not lifting the head also. You go there, X-ray, CT scan, MRI. You just went inside the cabin, that's all. Right? You even not opened up. Sir, headache, sir, MRI. For a headache, why you have to take MRI? No. Once I went to one hospital, my friend's hospital. Okay? I have taken my father there, and she is a dermatologist, skin doctor. I had taken my father to do a dermal-related problem. Then after some tests are completed, I just went to her and asked, how long you want my father to be in your hospital? She said, anyhow he has come now, ask him to take 2 more tests. I said, it is a Kalyan Mandapam that anyhow will come. It is not some more time and does the people. So it is the case of known people in a hospital, right? These are very funny. That means fault diagnosis in other fields of life is not proper nowadays. At least in our VLSI field, let us make it more straightforward. Fault diagnosis is all about fault identification and fault rectification. What is that? Fault diagnosis is all about fault identification. Now doctors are ready to rectify first before identifying. Right? So this is how it goes. Next. So we have test vectors, we have fault-free circuits, circuits with faults, and we have comparators. We have to compare now. See, when you are saying that you are wrong, you should say what is right. Correct or not? With right only we can compare wrong. For example, I will tell you one simple thing. I need somebody to help me out. Okay? Yeah, yourself. What's the name? Okay. Somehow. Thanks a lot. Actually, this weight is, what is this? See, I just have written like this. And one of his friend has come. Sir has written something 50 only. Let me change like this. What is this? 50 mg. Because friend no is very light to him. Okay? mg. Then once again I can double this. So some other person who is not very fond of him has come and has written like this. is that? Tons. Right? So what mistake I have been doing? What mistake I have done? I have just written 50 and I left it like this. Yes? If I would have written like this, then there won't be any issues. It looks very simple on the board. Yes? But what is missed here? I am missing the unit by which the 50 is having a meaning. Right? 50 remains there only. But when the unit changes, and the unit of measurement changes, the actual concept also changing. 50 tons here won't be the weight of that individual. 50 milligrams also not possibility. So 50 is given with kg as a perfect unit, then only it is giving some meaningful answer. Even false also are the same case. Okay? Here 1 kg is nothing but the standard with which 50 is compared. While defining the fault also, you should say the standard. Based on which standard you are saying it. Right? What is your reference? Reference value minus obtained value is called as error. Am I correct or not? Correct program, wrong program. The difference is the lexical error or syntax error. So this is how this comparator is required. When you compare these two, you will identify whether fault is there or not. Next slide. Next one. Yes. ATPG. ATPG means what? Automatic test pattern generator. We can generate the test patterns automatically to test whether fault